So welcome you all to this session on mathematics. I'm going to be covering functions and relations. That's the topic that we are going to cover today. Before we start, I just want to ensure that I want to give a few introductory statements. So first of all, this focusing on problems from IIT. Maybe I will do a few simpler problems, but mostly it is going to be, I'm going to take some problems from the recent IIT examination, JEE, okay, and cover them. So that means the prerequisite is that for you to be able to follow, நீங்க வந்துட்டு புக்கில் உள்ள லெவலில் நல்ல தரோவா. So you all should, even for mathematics, I do not know நீங்கள் யாரெல்லாம் எவ்வளோ பேர் பண்ணுறீங்கன்னு எனக்கு தெரியல. புக்கில் உள்ள மெட்டீரியல், அந்த ஃபார்முலா, கான்செப்ட்ஸ் இதெல்லாம் நம்ம தரோவாக படிக்கணும். அப்புறம் அந்த எக்ஸாம்பிள்ஸ் ப்ராப்ளம்ஸ்லாம் நம்ம நல்லா தரோவாக பார்த்து அண்டர்ஸ்டாண்ட் பண்ணிக்கணும். ஏன்னா இதில் வந்து சர்டன் கொஸ்டின்ஸ் நான் ப்ரிப்பேர் பண்ணி அதே கொஸ்டின்ஸ் வரப்போகிறது கிடையாது. மேபி உங்கள் போர்டு எக்ஸாம், உங்கள் ஸ்கூல் எக்ஸாமில் அந்த மாதிரி இருக்கும். பட் when it come to competitive exams, it is not going to be like that. So they are going to test your conceptual knowledge. ஸோ அப்போ நீங்கள் அன்லெஸ் யூ ஆர் தரோ இந்த கான்செப்ட், கொஸ்டினை கொஞ்சம் ட்விஸ்ட் பண்ணி டிஃப்ரெண்ட்டாக கேட்டால் உங்களுக்கு கஷ்டமாக இருக்கும். ஸோ இட் இஸ் வெரி 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 இம்பார்ட்டன்ட். ஸோ அதை நல்லா உள்ளதை ரீட் பண்ணிவிட்டு எக்ஸாம்பிள்ஸ் பார்த்துட்டு தென் நீங்களாக உங்கள் புக்கில் உள்ள எக்ஸசைஸ் மோஸ்ட் ஆஃப் இட் உங்களால் போட முடியணும். போட்டு ட்ரை பண்ணணும். இஃப் யூ ஆர் கெட்டிங் ஹேவிங் டிஃபிகல்ட்டி, அதெல்லாம் உங்கள் ஸ்கூல்லேயே ஆக்சுவலாக போட சொல்லணும். உங்கள் ஸ்கூல்லேயே இதர் இந்த கிளாஸ் ஆர் எஸ் ஹோம்ஒர்க். இது உங்கள் புக்கில் இருக்கிற ப்ராப்ளம்ஸ் எல்லாத்தையும் உங்களுக்கு போட கற்றுக் கொடுக்கணும். ஸோ ஐ எம் அஸ்யூமிங் தட் தே டூ தட். இஃப் தே டோன்ட், நீங்களாக அதை போட்டு அந்த லெவலில் நம்ம இருக்கணும். அட்லீஸ்ட் you should be able to do all the problems in your book. So I'm not going to do those problems. I'm going to take problems directly from JEE and do it. So it's a prerequisite. Okay. So with that, I think in the children ella mostly state board illa CBSE ah Kesha. Okay, inga I hope you are all able to hear me, right? Ellarkum.
Yes sir, yes sir. So mostly they are from state board.
Okay. Mostly. Fine. So my whatever from looking at the CBSE and the state board books, I think that state board book is, the syllabus is better. The Freud problems ரொம்ப நல்லாவே இருக்கு. அதனால உங்கள் ஸ்டேட் போர்டு புக்கில் இருக்கிற ப்ராப்ளத்தை நீங்கள் போட முடிஞ்சிருச்சுனாலே நீங்கள் கண்டிப்பாக யூ வில் பி ஏபிள் டு டூ ஃபேர்லி வெல் இன் JEE. ஓகே, ஸோ அதை நீங்கள் கண்டிப்பாக பண்ணணும். ஸோ வித் தட் இன்ட்ரோடக்ஷன், ஸோ ஐ எம் கோயிங் டு ஸ்டார்ட் சம் ப்ராப்ளம்ஸ் நவ். எனிபடி, எனி கொஸ்டின்ஸ் அட் திஸ் ஸ்டேஜ் பிஃபோர் வி ஸ்டார்ட்? Okay. The first topic, like I said, is functions and relations. Okay. So, do you all know what is a function? What is a relation? What is a function? யாராச்சும் சொல்ல முடியுமா? Suppose there are two sets. Relation is a mapping between those two sets. It's an ordered pair. Okay, mapping from one set to the other set. So any mapping set of such mappings is what we call as relations. Map will be based on can be based on some condition or can be simply a mapping. So that is your relation. function there are two special characteristics for a function. So, relation means simply mapping from one set to other. Function is a special type of relation. Okay. So, ரெண்டு முக்கியமான characteristics இருக்கு ஃபங்க்ஷனுக்கு. So, what are those? One is that for any A to B, ordered for A to B, suppose this is your set A. Okay, so this is your set B. It has got A1, A2, A3, etc. These are the values in A set 1. B set has got these values. And we can map anything to anything, in a relation. Okay. But if it is a function, any value in set A should be mapped to a unique value in B. Okay, a function of A cannot evaluate to multiple values in the set B. Set A we call as domain, and set B we call as codomain. So that means any value in domain should map to a unique value in the codomain. So that is your one characteristic of the function. The second characteristic is that a mapping should exist for all the values in the domain. So ஏதாவது ஒண்ணுத்துக்கு B there is no corresponding value அப்படின்னா then it is not a function. So for every value in set A or domain, there should be a corresponding image in set B, not in the codomain. Okay. That அதுக்கப்புறம் இப்போ what are the type of questions that we normally get அப்படின்னா there are a type of relation. Okay, types of relations என்ன இருக்கு? ரிஃப்ளெக்சிவ் அப்படின்னு ஒரு டைப் இருக்கு, சிமெட்ரிக், transitive. So does everybody know what are these three types of relations? Okay. Hey, hi, Geeta. Hey. Yeah, go ahead. Yeah, tell us, Geeta. I want to introduce Geeta. Geeta is a parent. So her daughter is in class 11. So she's teaching other people, including her daughter. So I presume her daughter is also in the class. So yeah, go ahead, Geeta. You want to say what is reflexive relation? Okay. Okay. Reflexive means an element in a domain is related to itself. So then that is called reflective. Okay. This if x a1 in our element, so it should be mapped to a1. Okay, it's the same value. So then that is reflective. Symmetric abdina, if a1 is mapped to b1, then b1 should also be mapped to a1. Symmetric. Transitive abdina, if a1 is mapped to b1 and b1 is mapped to c1, so then a1 should be mapped to c1. So this is transitive. A is related to B, B is related to C, then A is related to C. So these are the three types of relations. Okay. அதுக்கப்புறம் அதே மாதிரி டைப்ஸ் ஆஃப் ஃபங்க்ஷன்ஸ் அப்படின்னா I want to admit a few people meanwhile. அதே மாதிரி there are types of functions. Types of functions. What are the types? One is one to one. Very good. Or many to one. Okay, we said that any value in set A should be mapped to a single value, but multiple values in set A can be mapped to the same single value in B, right? So adu mari illama, so for every value in A1 there is a unique value B1, and that value B1 is not mapped to any other value in set A. So அது மாதிரி இப்போ A1 B1 மேப் ஆகுது, A2 B1 மேப் ஆகுதுன்னா இது many to one. This is not one to one. Okay, so that is many to one versus one to one. So other type of function is into or onto. Okay. Into அப்படின்னா all the values in the set B or codomain are mapped to there is a corresponding image in A. So every value in codomain is covered in the relation அப்படின்னா in the function. So then that is a onto function. But if every value is not covered, then that is an into function. அதுக்கப்புறம் then the how to count the number of functions, the number of relations. So இதெல்லாம் ஏன் சொல்றேன்னா these are the type of problems that you normally get in the conceptலாம் நம்ம. So we will do some problems on these concepts, and whenever we do the problem, I will explain the corresponding concept also. Okay. Okay. Now let's go to one problem. First problem. Okay. Now there is a relation xy equal to -2. Okay. So it is a function. Okay. We have to check whether it is a function. So something can be a function in a certain domain when the domain is something, but it may not be a function in another domain, because நம்ம பார்த்தோம் இல்லையா, domain எல்லாத்துக்கும் corresponding image இருக்கணும் function அப்படின்னாக்க. So it depends whether it is a function or not, depends on the domain. So அதனால இப்போ xy equal to -2 may be a function in certain domain but may not be a function in certain other domain. So we have to check that. So how do we check that? Is it a function, or if it is a function, then find out the domain and range of the function. It's a very simple problem. It is not from JEE. I took it from somewhere else. I do not remember, but I thought it is interesting to explain the concept, so I took it. Okay. இது மாதிரி இருந்துச்சுன்னா ஃபர்ஸ்ட் என்ன பண்ணணும், you have to write in terms of y equal to function of x. அந்த ஃபார்ம்ல கொண்டு வரணும். So it is -2 by x. So by simple algebraic manipulation we can do like that. xy equal to -2 can be rewritten as y equal to -2 by x. So if y equal to -2 by x அப்படின்னா, so for every value of x, y is unique, right? So you put whatever value of x, y will be a unique value. So it is a function. Right. Now, what is the domain? What is the domain அப்படின்னா, what are the possible values of x? Okay. For this relation to hold, what are the possible values of x? Okay. So you put any value of x, y can be calculated, right? Or is there some value for which y is not defined? But if y equal to -2 by x அப்படிங்கும்போது, if x is 0, then y is not defined, right? We know that something where denominator is 0, the function, that expression is undefined. Therefore, இப்போ நம்ம டொமைன்ல வந்து we cannot have 0. If 0 இருந்துச்சுன்னா corresponding image will not be there and it will not qualify as a function. அதனால if the domain includes 0, this is not a function. If domain excludes 0, then it is a function. So for it to be a function, domain should be, but it can be any other real value. அதனால you can put real minus 0. Okay. So this is your domain. So, and what is the range? What are the possible values that y can take? So y can also take any value depending on whatever value that you put for x. Y will be minus 2 by x. So if you put a negative value for x, y will be positive. If you put y positive value for x, y will be negative. So depending on what you put, y can assume any value. But can y assume 0? You cannot make y as 0, right? Because same logic. If y has to be 0, then x has to be infinity. So because x will be 2 minus 2 by y, so that means y equal to 0 cannot be achieved because whatever you put in x, so this we cannot get y equal to 0. So அதனால range is also same, or minus 0. Okay. So now did everybody understand? See, இந்த ப்ராப்ளத்துல புரியலன்னா நீங்க feel free to ask, and also you should try to do these problems yourself. There is, the classes are not going to be effective if I just keep telling something and you listening. Okay, so particularly in maths, okay, it's not going to work that way. So you all need to work out and do the problem yourself. So I'm going to put up the other problem and I'm going to give you some time. Okay, it's based on these concepts that whatever we have discussed so far. So I'm going to give you some time and ask you to do this problem. Okay, let's go to question number 2.
Sir.
My God. The second problem of the day. So I hope you are all able to see this problem, right? Says a relation x1 comma y1 related to x2 comma y2. So x1 y1 is in x1 is in the domain and y1 is in the codomain. So y is the codomain, x is the domain. So x1 y1 is related to x2 y2 as x comma y both belonging to natural numbers, and x1 less than or equal to x2, y1 less than or equal to y2. Okay, so it is set இருக்குது x1 ரெண்டு வேல்யூ இருக்கு. For example, you have a value 3 and 4. Okay, so this pair we will say is related to another pair 5 and 6. Okay, if x1 less than x2 and y1 less than y2, இந்த இதெல்லாம் வந்து codomain, இதெல்லாம் domain. There may be many other pairs that you can put like that. Okay, so it is given that both are natural numbers. Okay, so this is your codomain. So this is natural number, means இதோட set வந்து complete set வந்து all natural numbers. ஸோ அதே மாதிரி இதோட கம்ப்ளீட் செட் வந்து all natural numbers or pair of natural numbers. So I should not write like that. Any pair of natural numbers, okay? Like this, 3, 4 or 5, 6, any such pair you can write. So here also you can write all the pairs. And the relation exists if x1 less than x2 and y1 less than or equal to, less than or equal to y2. If given this, so you have to find out whether this relation is reflexive, symmetric, or transitive. So which combination? Okay. So please work on this, and I'll give you a few minutes. Okay. Check your internet. Is anybody having problem? Okay. Reflexive and transitive. Yes. What about others? யாரெல்லாம் போட்டிருக்கீங்க? Can you raise your hands, please? Marimuthu. Okay. Ita. Okay, and yeah, 2 more people it says. I'm not able to see those people. But anyway, since Geeta raised her hand first. So Geeta, can you tell me how you arrived at this answer? Can you explain?
Yeah. Because you gave already the 2 pairs, 3, 4 and 5, 6. So 3 is related to 3. Less than or equal to is given, so we can take equal to. 3 equal to 3, therefore reflexivity is true.
Okay, so so it is related to itself. So 3, 4, and you put 3, 4 on the other side.
Again, 3, 4,
because
3, 4.
The condition is less than or equal to, so it satisfies.
Yeah.
Because it's equal to is satisfied. Very good, very good. Okay.
Symmetry, it does not satisfy because less than means the other way it will be greater than.
Right.
So
because, if 3, 4 is related to 5, 6, and 5, 6 is not related to 3, 4 because 5, 6 is not
greater than. It is greater.
Right, not smaller.
So the order changes there.
Right.
Then
Good.
for transitive, I added one more pair. 3, 4, 5, 6, 7, 9.
Okay.
So 3 is less than 5, 5 is less than 7, implies 3 less than 7.
Very good. Good. So then the relation is reflexive and transitive. Option 3. Okay, good. What about others? Anybody else has anything to add to whatever Geeta said? Okay. So good work, Geeta. The solution is option 3, reflexive and transitive. Very good. So anybody has any question? If anybody did not understand, please ask now. Because these are the type of questions that you will get in JEE. It may not be like this. It may be different. you will be asked to check whether it is reflexive, symmetric, etc. So let me put up the next question. And is it same question comment? Okay. Can everybody see the problem? The problem is that the function R is the domain and A is a codomain. Okay. So R to A is given by f of x equal to x square by x plus 1. So this is a surjection. Okay. They use another terminology. I said many to one, one to one, into, on to, and all that. But there is another terminology that I want to explain. One to one is also known as injective. The function is injective if it is one to one. Okay. The on to is also known as surjective. The function is surjective if it is on to. Okay. If it is not on to, or if it is into, then it is not surjective, we say. Okay. And then there is another term, one to one and on to one, and on to. The function we call is one to one and on to is known as bijective. Okay, so in questions you might come across these terms: injective, surjective, and bijective. Okay. So given that, please look at this problem. This f of x equal to x square by x square plus 1 is a surjection. Okay, that means it is a surjective function or onto function. Okay. So then find A. A is a codomain, like I said. Okay. The domain is R. All real values. Okay. Please work on it. And
I have a doubt.
yeah, go ahead.
It is given to be onto.
Yeah, it is given to be onto.
But for both positive and negative values, suppose if I substitute 2 and minus 2, I'm getting the same f of x. So how can two values come in the domain for one image in codomain?
Onto தான கொடுத்திருக்கு. It is not saying it is one to one.
Right. Onto meaning வந்து கோடொமைன்ல இருக்க ஒண்ணுத்துக்கும் ஒரே ஒரு ப்ரீ இமேஜ் யூனிக் ப்ரீ இமேஜ் டொமைன்ல இருக்கணும்ங்கிறது தானே அர்த்தம்.
Correct. Every value in the codomain has to have a corresponding value in the domain. That is what onto means.
அப்ப ரெண்டு வேல்யூ இருக்கலாமா?
ரெண்டு வேல்யூ இருக்கலாம். Okay. So ரெண்டு வேல்யூ எப்ப இருக்க கூடாது? Then it is 1 to 1 க்கு தான் இருக்க கூடாது. So anybody has completed, please raise your hand. Very good. Marimuthu and Geeta, they have completed. Okay. Very good. Okay. So let Marimuthu, can you explain this time? What did you do? How did you do? So here is a set of all real values, okay, getting mapped to this something A, so that we have to determine what is this codomain. And the relation is x square by x square plus 1.
May I have a chance?
Okay, yeah, Geeta, you can explain. Yeah.
Is it R plus?
Yeah, can you tell me how you did it?
Yeah,
What are the
yeah.
steps? Yeah.
Yeah, definitely. But is it right? First of all, I want to make sure. R plus
Yeah.
is a codomain. I just substituted certain values, 1, minus 1, 2, minus 2. Since the domain is a set of real numbers, I chose some examples, 1, 2, 3, 4 values, and then including 0 also. So if I substitute x equal to 0, the right hand side is 0 divided by 1, which is again 0. So
Okay.
1 minus 1, 2 minus 2, 3 minus 3, I just tried. So for both positive and negative values, if I substitute 2 and minus 2, the same answer I am getting. 1 by 2 as the image. Similarly for everything. For every pair, because the right hand side is squared, x square divided by x square plus 1, the right hand
It's
side
always
is
positive.
always positive.
Right.
So 0 is also included, but R plus including 0. Plus means it starts from 1 or right side of 0. Is it right?
Okay.
So 0 is also one of the...
0 is part of the codomain. Okay.
Yeah.
Right. Then, how far does it go on the right?
So, 1 composing. Suppose I put y equal to 0, reverse it. The end it's a bit satisfies for all values. This is 0.
Can you take any values? Can the right hand side become 10?
Oh, only fractions. Is it only proper fractions? Because always the denominator is 1 greater than that. So it is proper fractions alone.
Right. So, right. Okay. So what is the codomain? How do you define it?
Maybe n by n plus 1.
Yeah, n by n plus 1 அப்படினா we have to define it, no? What values it can take?
Okay,
Proper
n by n
fraction
plus
correct,
1.
ma. You what you said is right.
Okay. The n belongs to positive capital N, natural numbers.
Okay, let's see if anybody else has got any other. I think other people also solved it, right? So, Marimuthu or anybody else who has solved it? Okay. Sure. Geeta, I think you, let me explain. What your said is correct. Okay. So it will be a proper fraction. That's all. Okay. So it can be, it cannot take value of 1 because denominator is always greater than numerator. Little greater, x square by x square plus 1. So it has to be a positive value, like you said, is greater than or equal to 0. And it has to be a proper fraction. It cannot reach 1. So all other fractions very big fractions are also included. 1 lakh or 2 lakh, 10 lakh divided by 10 lakh plus 1. 1 crore, 10 crore divided by 10 crore plus 1. You can define all of them because as we keep on increasing the value of x, this fraction keeps on increasing and goes closer and closer to 0, but never reaches 0. 1. It never reaches 1. So how do you represent it? It is a equal to 0 included, but 1 not included. That is what it is. Okay. Do you all agree? So this is what, it's a positive proper fraction. Like Geeta very correctly put it, but just, in mathematical terms, you write it like this. Okay. So let's go to the next problem. I don't want to keep on doing more problems. Rather than doing more problems, what is important is you should be able to do at least 1 or 2 problems or understand 1 or 2 concepts, all of you in the class. And that I'm not able to even determine because nobody is speaking, nobody is opening your mouth. So I don't know whether, you are following, able to do, not able to do. This is what I copied, right? Okay. If function a to b and a is all natural numbers from 1 to 8, b is also natural numbers from 1 to 8, find the number of 1-to-1 functions from a to b such that f of 1 plus f of 3 equal to 14. So like I said, there are some problems where they will ask you to count the number of functions, number of onto functions, number of one-to-one functions, number of relations. It's very commonly asked question. Okay, you should know how to count in these cases. Right. So try this problem. Your problem number 4 of the day.
What is the definition of the relation that is not given? How can we map? In what definition we have to map?
All one-to-one function. That's all. Anything which is one-to-one is acceptable.
We can imagine.
One
goes to one
can
goes to
be
2.
mapped to 1, then 2 can be mapped to 3, and so on. Anything can be mapped to anyone. Anything in the domain can be mapped to anything in the codomain. But the only condition is f of 1 plus f of 3 should be equal to 14. Oh, Jayashakti Sai has said something. Why don't you speak out? Then there are, I can't see all the messages all the time. Jayashakti Sai, are you there? Jayashakti, if you have any question, please ask what I want. I can't go on from the beginning once again, right? So what is your question you have to ask?
Unmute and ask me, Solina. Unmute and ask what whoever wants to ask.
Yeah, unmute and speak. Yeah.
I think my answer is, I don't know, only one. The number is one.
One. No, only one function can be defined. Is that
because
what you're saying?
8 plus 6 is 14. So f of 1 should be, 6 of 8 and 6 reverse way.
Yes. Yeah.
Either 8 plus 6 or 6 plus 8. So 2. 1, 8, 1 pair. 8,
Okay.
1 pair. 3, 6, 1 pair. 6, 3, 1 pair. So adding, so how to count? 2 or 4? 2. 2 is my answer.
2. Okay. Anybody else? Okay. See, the problem is that the domain has got all natural numbers 1, 2, 3, 4, 5, 6, 7, 8. So it's a 1-to-1. So there are 8 terms here and 8 elements on both the domain and codomain. One-to-one means all the elements should be mapped to all the elements in the codomain because it is function. All of them needs to be mapped. One-to-one means there are only 8 elements on the codomain. So everything should be mapped to something else. It's like, how many combinations can you make? Okay. So that is what you have to count. But the condition is f of 1 and f of 3 should add up to 14. So that means 1, like she said, the only combination that will add up to 14 is 6 and 8. So 1 can be mapped to 6 and 3 can be mapped to 8. Okay. Then what about the rest? This alone doesn't define the function. Function means everything should be defined, right? It should be mapped, right? So how many ways we can map the other elements? For each combination like this, 1 is mapped to 6, that is gone. 3 is mapped to 8. But there are 6 elements in the domain that is still unmapped and 6 elements in the codomain that are not mapped. They need to be mapped and there is no condition, which means in how many ways they can be mapped?
Is it 6 factorial?
Yes, it is 6 factorial. Because if you map 2 to 1, 2 can be mapped to any of the 6 remaining values. So for each one, then the next element, which is 4. So that can be mapped to the remaining 5 values and so on. Okay. So for each combination, this 1 is mapped to 6 and 3 mapped to 8. There are 6 factorial mappings you can define. That means those many functions you can define. So total number of functions you can define is therefore 2 into 6 factorial. Landeshwari. Okay. So in this context, I want to tell you something about how to count. Okay. Some theory I want to discuss now. But this is a common type of problem, counting. So you need to know that. Okay. Okay, suppose there is a domain has got, say, n elements. So let us say m elements. And codomain has got n elements. Counting. This is domain. This is codomain. Okay. Suppose we define domain and codomain in such a way that there are m elements in this, n elements in this. They can be anything. Okay. Just all we need to know there are m elements and n elements here. So how many relations are possible? Question is how many relations can be defined?
So 2 power m into n.
Yeah. Who said that?
So Rahul.
Rahul. Very good. Very good, Rahul. Very good. Yeah. So how can you explain more how you arrived at that answer? Okay. So for that, so all we need to do is see relation means is a subset of the cross product. Okay. So cross product means you make a set of all ordered pairs. Okay. So A1, comma B1. So let us say I name them as A1, A2 up to AM, and name it as B1, B2 to Bn. Okay. So what is the cross product? All the ordered pairs. First element coming from domain, second element coming from codomain. So like A1, B1, okay, A1, B2, like that. All the combinations that you write, if you try to write like this, all these ordered pairs, there are going to be m into n. Such ordered pairs will exist, right? Now you write a set of all such ordered pairs. A1, B1, A1, B2, A1, B3, and so on. So then A2, B1, A2, B2. It will go on. So like that you can see that, so there are going to be m into n elements in this subset, in this set. Okay. So m into n ordered pairs can be formed, and those m into n ordered pairs are part of this set. Now, what is the relation? Relation is a subset of this cross product. Okay. The subset of this cross product means just you can take A1 comma B1. That is all the relation. Rest are all not mapped. So that is a relation. So you can take these two alone. Okay. And that will be a relation also. You can take any two. These two alone can also be like that. So any subset you can take, that will be a relation. So the question is, if there are m into n elements in a set, how many subsets can be formed? Okay. So that is the formula for this 2 to the power of a. A. Okay, if there are A elements in a set, then there are 2 power A subsets that can be formed. Okay, so that is how it comes. So you can count, do it in another way also. So I mean, how this 2 power m comma n comes is you can take null is one element of the subset, right? So null is 1, so we can call it as, let us say, this is m into n, I call it as A, let us say. Then A venda, x. So then nullங்கிறது ஒரு எலிமெண்ட். ஓகே, ஸோ அதை வந்து நம்ம எக்ஸ் சி ஜீரோன்னு வச்சுப்போம். அதுக்கப்புறம் ஒன்னொன்னா எடுத்தோம் அப்படின்னா என் எக்ஸ் எலிமெண்ட்ஸ் இருக்கும் அதில், எக்ஸ் சி ஒன். ஒன்னொன்னா எடுக்கிறது எக்ஸ் பண்ண முடியும், எக்ஸ் டேர்ம்ஸ். ரெண்டா எடுக்கிறது அந்த மாதிரி ஒரு எக்ஸி டூ பண்ணலாம். கடைசி எல்லாத்தையும் எடுக்கிறது ஒன்று. So it's a sum of all this, so which is equal to 2 power. It can be proved that this is equal to 2 power x. Okay, this is basically from binomial theorem. This is 1 plus 1 whole to the power of x, so 2 power x. Okay, so that is how you count the relations. Next, let us say you count the functions. இதே செட் எடுத்துப்போம். Suppose there are m elements here. Now I am putting the question slightly differently. How many functions can be formed?
So q power p or n power m.
Okay. So anybody else? Rahul, good. So what about Geeta or anybody else? So how this is coming is, for you take A1, everything has to be mapped to all the to some element in B. So it can be a function only if m is smaller than n. Okay, if m is greater than n, then நமக்கு வேல்யூ இருக்காது இங்க. இப்போ m வந்து 10 இருக்கு, இங்க 5 தான் இருக்கு அப்படின்னா 5 நம்ம டிஃபைன் பண்ணிடுவோம். சாரி, ஒரு நிமிஷம். A1 to, you can map each element to corresponding element here. If okay, so each element can be mapped to, here n elements, right? A1 can be mapped to n. So again A2 can be mapped to n. So no n. So n into for each of the m elements, m times. Okay, so that is how it is, n comma m, like Rahul pointed out. So n comma m functions can be defined. Okay.
Sir, I have a doubt.
Yeah. Tell me.
Sir, how can we calculate the number of bijective functions?
Okay, I will come to that. Okay, so first the number of functions. So I want to make sure that everybody gets this. That it is how it is coming as n power m. So anybody has any questions?
Sir, if the empty relation is considered as a symmetric and transitive relation?
No. Empty, it will not satisfy that condition, no? So for symmetric and transition, there should be two elements. Okay, it's a pair. Okay, the empty will not count in that.
Sir, then what about single set?
Yeah, you give me an example. Tell me what is the problem. You give me write down the problem. Tell me the problem. Okay.
Say for example, the RB the relation, the A mapping from B, it contained only one element in the set.
Okay. So how many elements that A contain and how many elements are B contain? Or
So
is the relation? A has got one element.
Yes, sir. Sir, I said if the relation contained a single element, then the relation be transitive or symmetric, sir?
The relation contains, so suppose this has got multiple elements, okay, A1, A2, etc., AN, okay, B1, B2, etc., Bn. Okay. If the relation contains only one element, it cannot be transitive. Okay. So it needs to have, if A is related to B, that is the only element in the relation, then it is not transitive because you don't have B related to something else. You don't have a way of verifying, no, whether the transitive property is satisfied or not. Similarly, it is not symmetric clearly because if suppose A1, B2 is there, then that is the only element that is there. So B2, A1 is not there, so it is not symmetric. Okay? And if that one element is not A1, A1, it is not reflexive also. Okay. Does it answer your question? Muthukumar, you want to say something? Go ahead, Muthukumar. Muthukumar? Okay. So now the next is, so the same problem, okay? How many one-to-one relation can be defined? Suppose m greater than n, okay? So then how many one-to-one relations can be defined?
Sir, I think we use a permutation concept.
Yes, we use the permutation concept here, yes. But my question is, if m greater than n, okay? So there are 10 elements in A and 5 elements in B. How many one-to-one relations can be defined?
Sir, 10p5.
10p5. One-to-one. Those many one-to-one relations? Actually, if m is greater than n, you cannot define any relation because suppose this has got 10, okay? So you would have exhausted when you used up, n comes first, right? M is greater. So then you cannot map the remaining elements at all. Because one-to-one means, the two elements in A cannot be mapped to the same element in B. So therefore, if m greater than n, number of one-to-one relations is 0. Okay. Okay. Now, if m less than n, then what you said is right. Okay. So if m, then this is a condition first. Okay. M has to be less than or equal to n. Okay. So then only one-to-one relation is possible. Okay. Suppose m less than n. So how many one-to-one relations can be defined?
Sir, I think m greater than n is possible for one-to-one relation, sir. If two questions have a one set of solution of answer.
No. See, I'll write one set. Okay. So you try to define. So this has got elements 1, 2, 3, 4. Okay. So here you have got say 5, 1, 6. So can you define one-to-one? How will you define one-to-one? So you take 1, you map to 5. Okay. You take 2, you map to 6. So what will map 3 to? But everything in the domain has to be mapped, right?
Yes, sir.
So can we map?
No, sir.
Okay. So if m is greater than n, then number of one-to-one function is 0. Okay. So if m has to be first of all less than m. Okay. Suppose if m is less than n, suppose now in this case, so you got 1 and 2 here. So here you got 3, 4, 5 and 6. Okay. So this means m is less than or equal to n. Okay. In this case, how many one-to-one relations are possible? How many one-to-one?
M.
Sir, 6.
No. Think. So you explain when you say something, you also explain how you are telling that.
In this example, only 2.
Only 2. What are the 2?
1 goes to something, 2 goes to something else.
What? That something can be many, no? How many is what I'm asking.
1 goes to 3, 1 goes to 4,
Right?
1 goes to 5, 1 goes to 6, all possible. But 2 should also simultaneously go. So 2 takes one image, then The remaining will be only 3 for 1. Four comes.
1 can go to 4, and
One.
whenever 1 goes to any one of the 4, 2 can go to remaining 3, right? So how many total relations are possible? How many mappings are possible that way? 4 into 3. Okay. That is what is, I think somebody said that before correctly. It is N P M. This is the answer. Okay. But the condition is that N has to be greater. M has to be smaller than N in that case, or equal to. In that case, the number of one-to-one relations is going to be NPM. And in otherwise, if M is greater than N, it is not possible. Okay. So in this case, it is 12 is the answer. Okay. And if M and N are equal, then it is going to be NPN, which is N factorial. Okay. So that is what we saw in the last problem. Okay. So here counting, I think you are all in 12th standard, so counting problems, permutations and combinations you would have already studied. So you should be able to appreciate and do these kind of problems with a little bit of thinking. These are the rules basically. How many functions, how many one-to-one, how many relations. These are the type of problems you may get. Okay. I wanted to do many more problems, but running out of time. So I want to do one more problem, and then we'll close it. Or this is a very simple one. I think let's do this. Okay. I want to teach you one more concept. So I will do one more problem after this. Okay. Okay. Let f of x equal to mod of x minus 1 and g of x equal to e power x. E power x when x is greater than or equal to 0. Okay. And 3x when x is less than 0. So here f of x equal to mod of x minus 1, g of x equal to, it's got two values, e of x, e power x, when and 3x. This is what is given to you. Now is this function f of g of x, okay? In that case, now you have to define what is f of g of x. I see many problems coming like that, f of g of x. I think you would have studied this also in your 11th class itself. So f of g of x. So is f of g of x in this case, is it 1-to-1 or many-to-1? Please think about it for a few minutes. Let me think of another problem meanwhile.
So answer is 1 to 1.
Answer is 1 to 1. Okay. So who said 1 to 1? Rahul?
Sir,
Rahul? Yeah. So can you explain how you got 1 to 1? How
Yes,
did you
sir.
approach this problem? Yeah.
so first of all, f of x equal to modulus of x minus 1. Then g of x equal to divided into 2 division. One is if case 1 for x greater than or equal to 0 is for e power x. Then if x less than 0, 3 into x. So if first g of x is working in f, then f of e power x equal to modulus of e power x minus 1 if f greater than 0. For case 2, if f less than 0, f of 3x equal to modulus of 3x minus 1. So from this expression, f of g of x are different for f greater than 0, f greater than or equal to 0 and x less than 0. It implies that different inputs produce different output. Therefore, f of g of x is a one-to-one function.
Okay. So till the last step you did correctly, but your conclusion is not correct. Okay. See, yes, let me see if anybody else has got anything to say on this. Anybody else tried this?
I too tried it till that modulus. I tried the composition of functions. So I got the two modulus of e power x minus 1 and modulus of 3x minus 1. I got.
Okay.
After that, confused.
So f of g of x equal to modulus of e power x minus 1 or modulus of 3x minus 1. So now how do we say that this is 1 to 1 or many to 1? Okay. So just because it is defined differently into different regions, it doesn't automatically imply that it is 1 to 1. Okay. So in this case, you have to plot and see, let me see. For it is a function because for in the for each x in different segments, different y values are there. But for the same y value, do we get singular x value or multiple x value? So that is what is the question. So that is not obvious from this. Okay, just because these two functions are different in two different regions doesn't automatically imply like that. Okay. So in this case, what you have to do, in many cases, you have to do a simple plot, you can verify. Okay, so that's what you have to do. Okay. So if x is greater than 0, it is e power x minus 1 mod. Okay. So let us put x equal to 0. So this will be 0, right? As you keep on increasing,